more music on DavePlay.com.
Hello and welcome to class. In today's lesson, I will be wrapping up the topic Introduction to Chemistry. Alright, and our focus today is going to be on the scientific method. You should be able to state the steps in order, and then you should be able to state some adverse effects of chemistry and explain some of these effects. Okay? Now, what is scientific method? Scientific method is simply defined as the steps taken by scientists all over the world to solve problems, to create new theories, or make new discoveries. Okay? There are majorly 6 steps taken. It's summarized into 6 steps. The first, as you can see there, is observations. Observation begins with questionings. Questionings follows patterns. These patterns create a problem, and the problem forces the scientists to come up with a solution. Now, the solution is what we call hypothesis. Hypothesis is a statement that may be true or false based on your observations, okay, and answers to your problem. Now, you need to test your hypothesis. That leads us to the next step, which is called experiment. You carry out experiment more than once, 2, 3, 4, 5 times to ascertain if your hypothesis is correct. If your hypothesis is not correct with your experiment, you observe other things again. You go back and modify your hypothesis until you have an hypothesis that is in line with your experiments, and then you obtain your results. Now, after getting your results, which is the next step, you need to search if somebody else already have that result, okay? If nobody else have that result, you cannot conclude. And then, after conclusion, you share your ideas. You share your ideas for other scientists in the world to look into it and also conduct the same experiment. Now, if they conduct the same experiment and discover that what you are saying is true, it becomes a theory, okay? It becomes a theory. And then, if this theory remains unchanged over many years, okay, it becomes a fundamental law, we call a law in science, okay? So you can take a pause and look at the summary carefully. You have observation, leading to questions, leading to hypothesis, leading to experiment, leading to conclusions, and then result, which eventually leads to what we call theory, okay? Learn more about.
Now, scientists are always curious about the world and how everything works and why it works. And they are interested in inventing new things and making things that have already been invented even better. While scientists are doing their work of discovery and experimenting, they use a kind of roadmap. It's called the scientific method. The scientific method is a series of steps to perform to figure things out, to get to the bottom of things, to discover the answers to the questions of what and why and how things work, and to make them work better. Look at a light bulb. Not an LED, but an incandescent light bulb, one that has a glowing filament. How do you think we got the light bulb? The light bulb was not invented by just one man. The development of the light bulb took many years and many experiments, and many men all working the scientific method to invent one of the most important discoveries ever. Can you imagine what it would be like if we did not have the light bulb? We'd have nothing to wrap around the Christmas tree to make it glow through the night. And you would probably be tripping around in the dark if you didn't have a flashlight. And without the light bulb, you don't have a flashlight. The scientific method, when followed properly, can help you figure out the answers to some important questions. Let's run through a simple exercise to see how using the scientific method can work. There are many areas in the U.S. where winters can be brutally cold. Water freezes at 0 degrees Celsius. That's 32 degrees Fahrenheit. And if it happens to rain, the water turns to ice and snow. That's great for sledding and boarding and skiing, but not so cool for drivers. And roads can be very treacherous and dangerous when they're icy and slick. You may have seen snow removal trucks shoveling snow and spreading salt or sand on the highway to melt the ice. There is your observation. It looks like salt melts ice. But how much salt does it take to melt the ice? And how much salt does it take to prevent water from freezing? There is our step 1, using the scientific method, our observation. Now on to step 2, the hypothesis. We are going to make a guess. This might be our guess. If I use just a little salt, then the ice will melt. This could be our hypothesis. Or maybe you've come up with one on your own. There, finished with step number 2. What's step number 3? Right, experiment. We are going to test our hypothesis. Our experiment must be carefully planned. It must be able to be accurately repeated and be able to perform by someone else. Maybe this could be your experiment. We could use a plastic cup or a plastic bowl or a paper plate. I am going to use a paper plate and put in some regular tap water. Next, place your cup or bowl or paper plate of water in the freezer and give it time for the water to turn to ice. Remove the ice from the freezer and sprinkle a little sodium chloride, also known as salt, onto the ice and observe. See if the ice begins to melt. How much salt did you use? How thick is your ice? Whatever you do, you will have to keep precise notes. A lot of notes. There is no limit to the number of notes and explanation to give to your experiment. And now, what would you do next? Well, maybe you would return your container to the freezer and see if the salty water refreezes. You can run your experiment any number of ways. More water, less water. More salt, less salt. At the end of each experiment, you can come up with a new conclusion. See if your experiment can be repeated and determine if the salt is an effective way to melt ice. The point is to follow each step in the scientific method until you reach an answer, an acceptable conclusion. Back to the light bulb. Of the several men who took part in the development of the incandescent light bulb, Joseph Swan, Hiram Maxim, and Thomas Edison, it was Thomas Edison that developed a practical, long-lasting bulb. Thomas Edison tried 1,000 different ways to make an acceptable filament. When he was asked how it felt to fail so many times, Thomas Edison replied, "I have not failed. I've just found 10,000 ways that won't work." Now that's the attitude to have.
Let's now look at the adverse effect of chemistry, okay? The processes that are conducted through chemistry actually affect our environment in a very negative way, okay? There are adverse effects that are being controlled with what we call green chemistry these days, okay? Green chemistry involves zero pollution, okay? So number one of this adverse effect is pollution, okay? Product from chemicals, industries, radioactive sectors all end up polluting the environment, okay? For example, you go to the refinery, you see where they flare gases. You go to certain areas where they drill oil, you see oil spillages in river, which kills animals, is it not? Yes. Then we also have radioactive waste. Number 2 is drug abuse. Number 2, we have drug abuse. Drugs such as cocaine, heroin, morphine, because they have excitement effect on human brains, which also damage the brain, are being used by certain individuals, okay? Number 3, we have corrosion, which is the process in which metal break down slowly by reacting with oxygen and water in the environment, okay? A very typical example of corrosion is rusting. Now, rusting is the process in which iron react with oxygen and water to form rust or to break down slowly. Now, the type of reaction in which rusting undergo in chemistry is called redox reaction. What do I call it? Redox reaction. A reaction that involves the loss and gain of electron is called redox reaction, okay? Now, for corrosion to occur, there must be presence of oxygen and water, okay, with the metal, okay? Let's take an example. Let's conduct this short experiment. We have 3 samples. The first one contains a nail with only water. The second one contains a nail with air, and calcium chloride is added to take away any water that comes in, while the third one contains nail and water. Which of them do you think is going to rust? Of course, it's the third one, is it not? And why do you think it's going to rust? Because only the third one contains the condition necessary for rusting to occur. That is air and what? Water. Take note, when substances rust, it is the surface of the substances that what? Breaks off, okay? But with the case of iron, the process is a bit quicker, and then it deteriorates also. And then the surface keeps breaking and breaking. That's why you discover that over a long period of time, the iron becomes what? Totally deteriorated or even broken. But this is not the case with certain metal like aluminium. When aluminium undergo rusting, the surface that corrodes form a thin layer that protects the other areas of the aluminium or surface from further corrosion. We can prevent corrosion with two different ways. One we call the barrier method, and the other is called the sacrificial method. One example of the barrier method is by painting. Okay, if we paint the iron, it will prevent air from entering easily. Is it not? Yes. Number two is oil or grease. This also helps, okay, to prevent corrosion. While number three is what we call electrolysis. Okay, electrolysis is a chemical process in which we use to cover a metal surface like iron with another metal. Okay, the sacrificial method, we add a more reactive metal to iron, e.g. zinc or aluminum, so that when air and water react with the iron, instead of reacting with the iron, it will now react with the aluminum or what? Zinc. This will help to prevent the iron that is covered with the aluminum or zinc from rusting. A very good example is galvanization. Galvanization is a process whereby a metal such as a nail made of iron is coated with a zinc plate. So we can also say it's basically a barrier process, and at the same time a sacrificial process as well. Do you get it now? Yes. Alright, that brings us to the end of the lesson. Stay safe.